All right, time to start. Are we all there?
Yes, please.
Excellent. Right. Any thoughts? Any comments so far?
Professor, can I ask a question, an organizational question?
Mm-hmm.
I would like to clarify information about the assessment elements of this course. Will we have a final exam or homeworks? Thank you.
So you will have 2 courseworks that you need to do. I'm going to give you the question for the first coursework tomorrow. Okay. And you will have to submit, that's going to be a 1,500 word essay that you'll submit by the 11th of March. First one, that's a 50%. And then I'm yet to decide what the deadline is going to be for your next one, but I'm happy to have a chat with you to see that you don't have too many submissions that you want to make at the same time. But the second will also be a coursework, and that'll be 50% of the assessment. So there's 2 courseworks, and yeah, one you'll be working on it during this when I give the lectures, the other one probably submitting after I have finished on the 19th. Yeah.
Thank you.
And sorry, what about attendance? Is that taken into account or no?
No, you can still do your coursework even without attending a single class of mine.
Okay, thank you.
Yeah, I'm not making attendance mandatory. You know, if you're interested and if you can bear my voice, you can listen and come to the lectures. Okay. Yeah, I'll give you more information on that as we go along. Right, except one person. I think we are back on. Where shall I place you? I'll place you here. Right, so my slide is sharing, right? Yeah. So where did we leave off before the break? We looked at how is the climate changing? And we saw the climate has warmed up to 1.3 degrees Celsius. Now, from our current awareness about the problem of climate change, we know that this is not that very good. So the next logical question should be, what is the point of climate change law? Okay, is the climate change law being effective at all? We've just seen that the temperature has risen to 1.3 degrees Celsius. So we need to ask this question about effectiveness of climate change law. So, but what do we mean when we say effectiveness? What is effectiveness? There are multiple meanings, okay? One way to look at effectiveness is to say the extent to which the regime in question improves the state of the underlying problem, okay? We can say that it is effective if it has succeeded in improving the underlying problem. That's one way of measuring effectiveness. The second way of measuring effectiveness is the extent to which the regime achieves the objectives, the purposes which it set out to achieve. Okay. So in the case of the climate change problem, the first one, or the first option, which is the state of the underlying problem. Yeah. Now, what is the underlying problem? The warming temperature. So the question is, the UN climate regime, has it improved the underlying problem? Has it arrested the problem of global warming? The other way of asking about effectiveness is the UN climate regime has set a target. Yeah. Now, I did introduce this so far, but let me tell you what the target is. Or one of you can tell me what is our target with respect to climate change. Any idea?
Professor, reduce the temperature of the Earth.
Yeah, but do we have a particular number in mind?
Like 1.5 or 2.5 degrees Celsius.
Right. So we have to keep it at 1.5, but we should definitely keep it below 2, right? So that is one key target where the climate has to be. Now, what is our objectives? The effect of whatever we do is that the temperature is not going to go above 1.5. So what is the actual activity humans have to undertake? What is the target for the human activity? Anyone?
To reduce emissions at the first place.
Correct. So what is the target for the reduction of emissions?
I think it is 43 to pack it, or at 43 to decline by 43 in 2025. Yes.
Right. So we are looking at a particular date, and then we're looking at a number, right? So that is the one that is known as net zero. So we've all heard of the word net zero before this?
Right.
Yeah.
Yes, please. Yeah.
So essentially, as far as human activity is concerned, we are saying that at one point in time, we should not put any more greenhouse gases into the environment. There should be a zero. So it's not zero, it is net zero. Okay, what net zero means we'll talk about, but that's definitely an objective. So the next, so we can ask effectiveness in another way. We can say, does the UN climate regime achieve or has helped us achieve, get to net zero? Now, so there's two ways of addressing effectiveness. In one, we ask whether the underlying problem is addressed. The second, we ask whether the objective that the regime set for itself has been achieved. And remember, there might even be a gap between the two. But you might say, come on, you can't change the goalpost. It takes a long time to agree on something like this because everybody in the world has to agree to this. So if we say we are going net zero, then we go net zero. Okay, so there is, and it's possible if the world destabilizes a lot more, then maybe even net zero is not enough for us to address the underlying problem. Okay, this is me purely being hypothetical. All I'm trying to do is trying to illustrate these two different meanings that we can have when we ask this question: how effective has the climate change law regime been? Okay, so now let's look at if our target is net zero, right? Let's look at how we are breaking this down in various ways. So what is a per capita emission? What is a country's emission in 1 year? And so on and so forth. So let me introduce you to a different tool that you can use, which is this Our World in Data. Let me just share that screen and show you how you can obtain some data, because this is going to be necessary for you to do in the context of your assignment as well. Yeah. Okay, here you go. So this is a website that is quite user-friendly, ourworldindata.org. Some of you may have come across this for other types of data as well. So this is about carbon dioxide and greenhouse gas emissions. You can take your time to read this, but what I wanted to show you today was basically this particular tool over here. Okay, now you can play around with this particular tool. I'll show you a little bit of No, okay, that is fine. Yeah. All right. So you can see my screen here. Firstly, you can look at different types of agents that lead to warming. So you can look at CO2 emission, or you can look at all of the greenhouse gas emissions. Now, another term that is you might find in literature is CO2 EQ, meaning CO2 equivalent, right? And what that means is they could be talking about nitrous oxide, or they could be talking about methane, which are all greenhouse gases, but they equate it to. So rather than saying each of the GHGs, they just say carbon dioxide equivalent, meaning they are talking about all the greenhouse gases. Now, later on, I'll show you a slide where the warming intensity of each of these greenhouse gases is different. Okay, so carbon dioxide warms the atmosphere to a certain level. Methane, like one molecule of methane, warms the atmosphere way more than one molecule of CO2. Okay, so different capacity, different GHGs have different impacts of warming as well. All right, so you could play with looking at different sort of charts, okay? But I'm going to stick with just CO2 over here. Territorial is one variable you can add, or you can do consumption based. I'm going to keep it at territorial. There is all fossil fuel emissions. There is land use change separately. All these are separate terms. What I want you to do is just play around and become familiar with these terms so that as we go along, you'll see, you'll get a better understanding of them. But this is a very efficient way in which I can introduce you to some of the common words and concepts you will find you come across in climate change law and policy. So I'll keep all fossil fuel emissions. Then we'll play around with this a little bit. Per capita, okay, so per head. Now over here, what you can do is you can add countries, all right? So I can add different countries. Now shout out some countries you're interested in. Currently, China, India, UK, United States, and the world is there. I can remove the world for now. Any other country you want to see a graph of?
Russia.
China.
Russia.
Pakistan.
Right. Pakistan. China's already there. Anything else?
Maybe Brazil.
Brazil. Yeah. United States is there. Let me put United Kingdom. Oh, that's already there, right? Right. Russia's already there. Any other continent that's not been represented?
Maybe Saudi Arabia.
Saudi Arabia. India is there. Let me put Nigeria because that's another big country, and that's Africa then covered. All right, let's play with this. You can play with, you can also look, cumulatively, like, Europe, world. So there's many things that you can do. So what are we looking at over here? Per capita emission, meaning carbon dioxide emissions from fossil fuel industry, land, you can forget that. So per capita emission, basically the population divided by the CO2 emissions. Right, so tell me how you read this graph. Who has the highest per capita emission?
Saudi Arabia.
Saudi Arabia, yeah. The lowest per capita in this?
Nigeria.
Nigeria. So do you find anything surprising here? Is there anything here that you see which is counterintuitive to you?
Yeah, like as per population in the Saudi Arabia concerned, the per capita carbon dioxide emission is very high.
It is, isn't it? Yeah.
Yeah, it is.
So what I'm going to set actually as a question for you guys is, and this is going to be your first assignment, is to actually try and look at the reasons behind some of the trends you're seeing. Okay, so this is a per capita trend. Now let us look at per country. Now let's see how things work. What's changed over here now?
China is leading.
China is the highest.
It's like out of the scale.
Yeah.
Why? Any speculative reasons?
I think because there are many.
Industrialization.
Industrialization, manufacturing, yeah?
Yeah.
Their production, they are basically the producers for the world, isn't it? But these are all territorial, right? So that means it's coming out of the territory of China. And the UN climate regime, the nationally determined contribution, is also territorial in nature. It basically says, I don't care if China is producing most of the things we use in the UK, but it counts as Chinese emissions, right? So there is a territorial basis. That's because, I mean, that's the way in which you're going to enforce law, right? So those of us who are lawyers clearly know I cannot go and enforce UK law in China. China cannot come and enforce over here. So here we have a major problem in terms of how consumption takes place, where production takes place, and where regulation takes place, right? Right. So now you have interesting changes. Nigeria seems to remain the same. United Kingdom seems to, yes, come down. Now another is cumulative. Yeah, so far what they have done from the first year of recording, which is from 1750 to 2022. You can see how the shifts are going. United States now sticks out. China still sticks out, and then you have a crowd there below. And then we look at, start getting a little bit more nuanced in terms of where is the energy production coming from? So carbon intensity of energy production will increase depending on the source of energy production. So let us say if it is solar energy, then the carbon intensity will be lower. Let us say if it's based on burning natural gas, it is going to be higher. But even higher will be if it is based on petroleum. So now it's very interesting. What do you observe here? Who is on top?
Nigeria is part of top 3.
Nigeria is part of top 3. Yeah. And so far we haven't seen India top in the other charts, but it's topping here.
Yeah.
So what is the source of energy in India? Main source?
I guess fossil fuel.
Which fossil fuel?
Petroleum
One
products.
we've not. Sorry?
Is it petroleum products, oil?
Nope. Nope.
Charcoal.
Coal, Professor, coal.
Coal.
Charcoal. Yeah.
Yeah, coal, because India is unusually poor, okay, compared to so many other natural resource that it's rich in. It's very, very poor in oil, gas, petroleum. Whereas if you look at then Nigeria, there it is potentially more oil and gas, right? Because Nigeria produces a lot of oil and gas, but I'm not very sure. And, you know, if you're choosing Nigeria as a country you want to look into, then you can tell me whether Nigeria is actually consuming a lot of the oil and gas it even produces, because I doubt it doesn't do as much of it. But there's a lot.
They consume a lot of charcoal like coal because I mean there's high amount of burning, bush burning and felling of trees in these part of the country.
I see. Okay. So their consumption also similar.
Yes,
like
yes.
India.
I was even thinking they will be a little bit higher because there's so much burning in the West African countries.
Yeah. Very interesting, isn't it? I mean, we are at the moment literally scratching the surface and we're speculating about this, but we need to do a lot more analysis on specific countries. Of course, in international climate change law, we don't go according to what municipal policies do, but generally in law, we don't do that, international law, but in climate change law, as I mentioned before, the national nationally determined contribution is a part of an international obligation. So then we need to analyze why emissions happen in each country and whether the nationally determined contribution includes policy to address those specific sources of high emissions in their respective countries. Yeah, so that's the context in which looking at these graphs gives us an idea. Now, just for showing you another feature, let me play you a time lapse. This is going to show you from right at the very beginning. All right, so the data for this is only from 1965, but actually there's the per capita is actually pretty cool. So because it takes us from 1750, let me show you the time lapse of it. Industrialization, UK. So you find UK, the only country in the beginning. United States then joins because they are getting industrialized. Then Russia is joining, right? Then interestingly, India is joining. That's because it was under the colonial power of the UK. Then you start seeing 1900s and all other countries moving in. Yeah. This is up to 2022. How is the country's annual? This is very interesting. If you are, let's say, using a framework of climate change as a historical issue, then you're going to be looking very much at this graph in a lot more detail. And you're going to start picking out the reasons behind how those curves are formed. Okay. So, for example, you could look at let's say discovery of oil and gas and then place that around over here. Okay, that's a good, so you see Saudi Arabia, which is a quite good indicator for when there were large deposits discovered around that time. And then you start seeing, and it's so instructive. So if you keep going down the curve, you start getting more granular detail and data, right? Okay, so use this tool to be able to do your analysis. So it was just me introducing you to the various features in this tool. I mean, what I've introduced here is not exhaustive, but it should get you going. All right, so all of this, you know, basically is telling us that emissions are rising. The different countries have different contributions to it. There's different ways in which you can break down this contribution as well. But let's go back to our fundamental question of effectiveness, which is what I was dealing with when I started showing you this tool. So, the next 5 slides are snapshots of the 5 key indicators that will help you analyze in more granular detail what policies and what reasons behind policies for the emissions. Okay, so this is just screenshots captured from what we saw just now. And I have added a few more countries in there, and it gives you an idea of a profile of countries that are representative of, you know, around 202 or 3 countries which are part of the UN climate regime. All right, so when you get the slides, you could just have that just to remind you that that's where you need to go afterwards. So how effective is climate change law? Now, let me try and answer this in various ways. You will find literature supporting each of these, which I'll include in your reading list later. So this is a difficult question to answer. We have to admit it. Why? Because linking a legal regime to an environmental outcome is complex, it's uncertain, and is discontinuous. So just let's stop and think. In what other area of law do we actually use a cause and an effect relationship? Let us take up criminal law, okay? Governments around the world spend a lot of resources trying to say that they have reduced crime because of policies that they have put in place. They collect a lot of statistics about crime, and it's not difficult to collect statistics about crime because, you know, if one person gets killed, then the police are called in. So we can easily look at the police recording of crime and try and get data. Okay. Now, the same thing we cannot do if it is contract law, because nobody has to go and register. If I go and, buy a property, I don't need to tell anyone that I am buying that property. But of course, if you have a property register, then you'll have those details. But at the same time, if I rent a house, that transaction is going to be not going to be recorded anyway. If I buy a phone, that's not going to be recorded, right? So data sources for certain areas of law are more easier to come by. And certainly crime and crime data is used a lot in criminal law and in criminal law reform. And now, why did I give that example? Just because, right, we have a law on murder, can we easily answer the question, has the law of murder prevented the commission of murder? Okay, maybe that's not the objective. We know that there's always going to be wrongdoing, but whether it is at level acceptable to the people living in that city where we have the data for. Okay, now even just that level of causal connection, the law of murder operating in that country and the levels of murder reduced in the country, the variables there are not that many, but it's still very difficult to make that causal link. Okay, because you could have maybe increase in education or better provision of housing and other socioeconomic benefits, which might then reduce crime in a certain way. So it gets quite complex. So that's just a familiar example to take to see whether we can answer that question in something so complex. Now, why is this more complex than data and crime, making that causal link? Because first of all, the problem is a global problem. It spans different jurisdictions, okay? Therefore, the complexity becomes even more. The uncertainty, because every time the way we measure various variables in the weather systems is improving or it's actually changing. And it's also discontinuous. Like you saw in those graphs, just those 5 different elements, we didn't have data for one of the elements from as long as we had data on the other element, right? So this kind of evidence-based policy making, which is a feature of climate change law, is by its very nature complex, uncertain, and discontinuous, and therefore it is a difficult question to answer. So now we can ask, okay, we know this problem already really exists. Now, we saw the graphs. There is a steady increase in the greenhouse gas emissions since 1992. Now, I put the date 1992. That is because that's when essentially the climate regime was beginning to take shape. Okay, and we'll see in a minute why 1992 is a significant year. So since that time, up to 2022, the graph we saw, or the update we got was December 2023, it has only been rising. So can we then say that climate change law is ineffective? Okay, it's a difficult question to answer. We're not very sure, but can we say it is ineffective? Right. Now, let's start. The first point to answer that question is the inadequacies of climate change law is definitely a part of the explanation for the problem of increasing emissions. So we are saying, I accept climate change law is inadequate. Now, remember, I'm not saying ineffective, I'm saying it's inadequate. Okay, that means it's actually addressed the problem to a certain extent. Now, how do I justify that? By asking a different kind of question. So when I say how effective is climate change law, the question I'm asking is, has climate change law induced any changes in the state behavior in the right direction? i.e., that is, towards greater mitigation efforts and better adaptation. Yeah. So now you get a different question that you can ask about effectiveness. The answer to that is quite clearly yes. Yeah. So global average per capita emissions are expected to decline because of the Paris Agreement. Why? Because of the nationally determined contributions, which lays out a plan for emissions reduction. And there is also a clear and increasing trend to take national action. Now, let's just go back to that climate, the thermometer that we saw. Let me share the thermometer with you. And let's look at some more details in that thermometer. So let's look at this aspect of the thermometer. What it's saying is, if we didn't have any policies and action, okay, and remember, as part of climate policy is climate law. It's one of the tools in policy. If we didn't have any policies in action, we will be, the prediction is 3.4 degrees Celsius rise. But because of the policies and actions, the nationally determined contributions given up to the second round until 2023 December, the rise that is predicted is 2.7 degrees Celsius. Okay. So if we actually then look at a lot more pledges that go along with the NDCs, we could reduce that to a rise which is 2.1 degrees Celsius. If we say that all of this is actually satisfied and fulfilled, then the optimistic scenario currently is 1.8 degrees Celsius. Okay. So now by asking the question in a different way, we have now come to a different answer. The first question we asked was the global temperature is increasing. The more treaties we have, the more the global temperature rises. And that's what often skeptics talk about. But the other question is, what is the change in state behavior because we have policies? Now, if the UN climate change regime was not there, then we are heading towards 3.4 degree average temperature rise. But because all this is there, we are heading to 2.7. But then there's other policies apart from that, which a combination of which could lead to something. So overall, that means if we get better at doing climate change law, we have a good chance of keeping or getting to the goal that we desire to have. Okay. So that's one, a second way of asking effectiveness. So that thermometer right there showed you a clear and increasing trend to take national action. Now let's ask another question. How effective is climate change law? Okay, now we start coming to the nuance of law and policy. Has climate change law done as well as it could politically? i.e., was the Paris Agreement as successful as it possibly could have been? Now, there are two temperature figures that keep getting talked about in academic literature, in media, in policy documents. One is 1.5 degree rise, another is 2.0 degree rise, right? Now, we can put this question of 1.5 or 2 in this context. Could the Paris Agreement have got a better outcome of saying we shouldn't go beyond 1.5 or we should keep at 1.5? Because the Paris Agreement does say up to 2 degrees, but ideally we want it to be 1.5. So was this a matter of the negotiators not extracting as much as possible from that particular round of negotiations in 2015 that led to the Paris Agreement? Now we can put the same question, and I will ask you to reflect and think about this once I've told you what the latest outcome is. So the Paris Agreement was in 2015. After that, every year, the UN climate regime countries, or the state parties to the climate regime, meet up. Okay, so they usually meet up end of the year, November, December. So the last one we have had then is 2023, November, December. And that was held in United Arab Emirates. It was held in Dubai. So the Dubai COP, the Dubai Conference of Parties to the United Nations Framework Convention on Climate Change. Now that, the question we can ask is, was the Dubai COP as successful as it possibly could have been? Could they have negotiated a more ambitious consensus? Okay. Now, can I ask any of you to comment on that? If any of you are following COPs, okay, I am aware I'm throwing in COP here without any explanation about it, but I'm hoping some of you know public international law and know that treaties often are followed up through the conference of parties to the treaties, and that's what this is. But if anyone has a doubt around that terminology mechanism, do feel free to ask me a question around that. So, any thoughts on these climate COPs? Have you heard about the term climate COPs or COPs? Or COP, to be more precise. Anyone? It's a bit late in the day for you guys, isn't it? No? Okay, I will talk to you about and give, but are you all there listening? Or am I talking to myself?
Yes.
We are here.
Okay. Okay, brilliant. Okay, perfect. Right, so what I'm going to do is keep the thought. Was the Dubai COP as successful? And I will do a separate presentation. I'll do a separate presentation on the Dubai COP, what happened, etc., etc. Next, we're going to go to something that is a bit off the lecture structure, or I didn't put it in the lecture structure, but it's very relevant. We are going to look at this concept of a bigger problem than climate change, okay? Because there is an underlying problem that has been identified by Earth systems scientists. Since 2009, this has been a topic of discussion, and this has also led to more action in the forums dealing with climate change, be it national, be it private, or be it international. So the question I'm asking over here is climate change an isolated problem? Okay, and depressingly, the answer is no. Climate change is not an isolated problem, right? I'm introducing to you two terms over here. These two terms come from natural hard sciences. They come from geologists and they come from systems scientists, Earth systems scientists. So the first term you need to become familiar with, and you can, do your own bit of digging, but I'll also give you a reading list around this, is this concept known as a planetary boundary. So in law and in common parlance, we call the problem of climate change or global warming. But Earth systems scientists call it a breach of a planetary boundary, breach of a climate planetary boundary, right? There are 9 planetary boundaries, okay? 9 planetary boundaries, which all are interconnected big natural systems, okay? So Earth's scientists study the natural phenomena or natural ecosystems at the level of the planet Earth, okay? Now, we are all familiar with systems like rivers or a forest. These are all some things we are familiar with. The systems that are bigger than all of this, the systems that sustain our rivers, our forests, are considered to be planetary systems. And these systems, to function, to remain functioning the way they should, which is basically to support flora, fauna, humanity, etc., they have a certain internal integrity. Yeah. And that is bounded by this concept of a boundary. So if it loses internal integrity, it breaches its boundaries and it becomes destabilized. So the planetary boundary framework, PBF, is recognized as something that we need to be aware of. Now, why suddenly now we have to be aware of it? When I say now, give or take from 2009. Okay. Now, 2009 is not when the problem arises. 2009 is when the first publication comes out on the planetary boundary framework. That means to do their research, they would have done it at least a few years before. And the problem to have actually existed for them to do research must have even been a little bit further earlier in time. Okay. So that means give or take, we can use 2009, okay, as our, when I say now. So why now? When we say now, we need to think about planetary time, okay? And planetary time, and this is now we're going into the field of geology, and in particular, what's known as stratigraphy. All of this will be in the literature I'm going to give you, but you don't have to think so much about which field it falls in. But if you're curious, I just mentioned it. So there is this concept known as epochs in geology. Okay, epochs is a way of measuring time. You know, like we say age, like we say epoch is also an English word, but that's not, in English, in general English, we don't use it like how geostratigraphers use it. So epoch, what is being claimed is that the world or the earth has entered a new epoch. Okay, that new epoch is called Anthropocene. What did we have before this epoch? We had something called the Holocene. Now, what's the difference between the Holocene and the Anthropocene? In the Holocene, the earth and its natural features was responsible for regulating its own behavior. Okay, that's a Holocene. If you and I existed during Holocene, and we did exist during Holocene, we didn't have an impact on how the river is flowing or what is the composition of a soil in a place. We didn't have much of an impact. But now what scientists are saying is we have come out of Holocene and we have entered Anthropocene, which means the whole of the physical earth is capable of being affected by human activity. So we have entered a new epoch in geological time where anthropo or human is a key factor in changing the physical activities of the earth. Okay, so it just shows how as a race we have progressed. So in a way it's a triumph of how much we can achieve. At the same time, the question is, do we have the wisdom to see where our power is going? Okay. So when I say now, in the Anthropocene, where human activity can determine even a lot of how physical Earth is, we need to take account of planetary boundaries and not breach it. Yeah. And like I said, out of the 9 planetary boundaries, climate change is only one of them. And currently, we only have a law that can regulate climate change. Another boundary that is considered a core boundary along with climate change is biospheric integrity. We might argue some aspects of international environmental law and national environmental law will help in biospheric integrity, but that's going to come out pretty weak because we don't address all aspects of biospheric integrity. We might address, like, for example, the destruction of the Amazon, but that still doesn't mean we have addressed biospheric integrity as a whole. So this is another whole separate topic. But what I wanted to introduce you is the context within which increasingly climate change is coming to be understood, right? So a global focus on climate change alone is not actually sufficient for increased sustainable development of humans on Earth, okay? So when it comes to climate change law, we can happily address climate change as a problem. But when we look at sustainable development, there is no specific law around sustainable development. Well, there are sustainable development goals, but that is not law. Okay. But if we want to sustain ourselves, we do need to look at all of the different Earth systems that we seem to now have the ability to be able to affect. So to give you a quick idea, this concept of planetary boundary. So this graph is here. I don't want you to read those small letters in there. You don't need to read it right now. The only thing you need to look at is this boundary, the concept of a boundary. How do scientists place the boundary? A key principle in environmental law is responsible to work along with the data to establish this boundary. And that principle in environmental law is the precautionary principle. Okay, what is the precautionary principle? To try and address an activity before a harm is actually caused. Okay, now, you have a green zone here, you have a yellow zone here, you have a red zone over here. Now, a planetary boundary, where my cursor is running right now, could actually be placed anywhere in this yellow zone over here. If you apply the principle of precautionary, if you apply the precautionary principle, then you are placing the planetary boundary here between the yellow and the green zone, and not in between, in the middle of the yellow zone, which you could have potentially done. Or, you know, if you're very risk-taking person or a risk-taking body, you're going to put your planetary boundary at the edge of the red zone and the yellow zone. Okay. So because of how the precautionary principle works, along with the data we have about the safe zone, we are now placing ourselves at this part of the threshold. Now, you might ask, where exactly is the planetary boundary for climate change? Now, just so I can ensure that you're all still listening and not using my voice as a lullaby to nod off, because I do that sometimes, you give me an answer. Do you think 1.5 degrees, which is what the Paris Agreement enshrines as the acceptable level of temperature rise, do you think that is where the Earth scientists might put the figure as well? Take some guesses.
Seems that no.
A very good guess. Seems no, yeah. Why do you think? Why are you saying, you know, Paris Agreement might put it a bit higher? Oops, I couldn't hear you.
To be honest, I've read some works, but I don't remember exactly what it was. And I've heard as well that the real scientists, the Earth scientists, that they say that the agreements of the Paris Convention, it is not very helpful for the real world situation.
It's true, it's true.
Yeah.
Yeah. So, I mean, of course, it's as it is, it's quite difficult, right? To reduce and to try and keep 1.5. As you can see, we've already reached 1.3, you know, and in fact, they say that is already a conservative estimate. I even hear up to 1.48 from some other estimates, all right? So whatever it is, we have definitely reached 1.3. So it's quite difficult. Now, if you want to give some hope that we can try and keep it at a manageable level, then you're going to try and wrangle as much as possible at a higher level. Okay, then we can try and push it lower, but that policy is not there anyway. So the planetary boundary that for climate change is actually placed at 1 degree Celsius. Okay, not even 1.5. So overall, yes, a bit uphill task, impossible task. Each of us might have views on it. So the The last slide in this presentation today is here. So I told you about 9 planetary boundaries. In 2009, when the Earth scientists first assessed the boundaries, they only were able to assess 7 boundaries. And when they assessed the 7 boundaries, they also looked at whether we have crossed those boundaries. So 3 boundaries were crossed in 2009. In 2015, 7 boundaries were assessed and 4 crossed. Okay, and in 2023, now we have full assessment of all the 9 boundaries, and alarmingly, 6 boundaries had been crossed. Okay. Just a quick introduction to the 9 different boundaries. You've got stratospheric ozone depletion. We have a climate regime that directly relates to the control of gases that harm the ozone layer in the stratosphere. We will talk about that. It's quite a success story in climate change law. Then we have atmospheric aerosol. That's another boundary. Ocean acidification. Then we have biochemical flows. Some of these might sound vague. Some of these are can be very specific, what we can understand. But reading the literature will give you more idea. I mean, I haven't even finished reading all of this scientific literature. I use like this ozone one a little bit, and I go into the earth science side of climate change a bit, but it's a vast field. Then you have freshwater change, land system change, biospheric integrity, you've got climate change, and then you've got novel entities, right? I mean, none of them immediately rememberable as such, and they all look disparate as well. But the Earth system scientists have a clear parameters for how they define each of these boundaries and what part of the Earth systems and why. But 2 things worth remembering is there are 2 core boundaries out of these 7 boundaries, and one of them is climate change and one of them is biospheric integrity. And out of the 6 that we have crossed, or according to the 1 degree Celsius, which they put as a planetary boundary, we have crossed the climate change. We've also crossed biospheric integrity. Okay. Of course, it's a question whether once you cross it, can you actually turn back? Yeah, God forbid, hopefully that is the case, that we can actually turn back. There's a lot of elasticity. These systems actually respond to change. Okay, so as we're able to push the boundary out, we should be able to address changes such that we can step back. Okay, we can reverse some of this. In climate change, certainly, we know what the cause is, and we know quite clearly, we have a lot of knowledge on how systems, human systems, like our transport system, our energy system, our land use system, our agricultural system, how they contribute to, we know quite a lot of detail. So our hope lies in both a combination of using data, using a clear knowledge in real time of what's happening to the environment, and how we do our activities, and combining that with policy as well as legislation. Each cannot work on its own, okay? Because if humans are involved in doing something, we do need the policy, right? Because that's the only way in which we regulate our human activity. At different levels, we do it in different ways. We, as I've introduced you in the beginning, we use, we are specifically only looking at climate change law, but it interacts with so many other efforts, okay? All right, so let me finish this first sort of lecture session right here. I want to have a little bit of time for question and answers, clarifications. So let's use that time now for question answers. Can I also invite you to come on camera so we can have a conversation? Hi, Pankaj. Any feedback from you on the first lecture, my pace, my content, anything that you felt?
No, Professor, everything is okay. Good.
Who's that from? I could see you. You were all coming and going. Is that Zahur's view?
I think it was from Pankaj.
Oh, it was from Pankaj.
Yes.
Was it? I didn't see him unmute. All right, okay. Any other comments from anyone? Am I being too fast, or well, I can be boring. Don't even mention if I'm boring, but
No, I think we will need the recording of this lecture in our Telegram chat and also some material to read, because it's the first subject and we don't read about climate change subject.
yeah, it's recording both, so I'll find ways in which I can share. It might eventually be an unlisted YouTube link. Okay. Okay, any questions on any of the aspects? The nature, the features, effectiveness, how to measure, how to understand climate data. All of these were topics that we covered in the first introductory session.
Yeah, I have a question.
Yeah.
So we talked about the categories of climate change laws, and we had the environmental aspect, the economic aspect, and the justice aspect. I don't know if you are familiar with Lawrence Summers' memo in 1991, when he wrote about transporting or moving the dirty industries to less developed countries. I guess you might have read about it. I don't. If you have any idea about that, what is your take regarding his justification for why dirty industry should be moved from developed world to the less developed world as far as climate change is concerned? Because per the memo, I could see that he was speaking from the economic perspective to the neglect of the environmental aspect and the justice aspect. He was criticized for this position, but in economic sense, it was very practicable. In maybe environmental or natural law, you may say he was insane, but this earned him an opportunity to be promoted in different form. He even became the president of the Harvard University at that time. And since then, you can see that there's been a position on how climate laws are being taken. We may argue, I mean, you may disagree, but you can see clearly across the world that most of the climate laws are geared towards economic perspective, even though it is not. There's a thin line between how these laws are made, but many people look at the economic perspective to the neglect of the other parts. But they will explain to you that, okay, when you are able to cover this perspective, then you are literally covering the other aspect of the climate actions or problems. So I wanted to find out if you have read it before, or maybe you've heard it before, your position of his justification as to how dirty industry should be moved to less developed countries. Thank you.
Thank you. Very perceptive. I think the main justification that he gave was, I think he took into account environment, and he took into account primarily economics. What he completely neglected was the justice issue. Okay. Why am I saying he took into account the environment? Because the way we use environment in law it's very specific and bounded. Because when I say environment, I'm only talking about the environment in the UK, because that's how environmental laws in the UK will only protect UK. Same with the United States. So in order to protect the environment of the United States is why he actually proposed that economic solution. So I think he used both of those justifications. So he didn't ignore the environment. But looking at it from 2023, he ignored the Earth system's perspective. Because by moving it to another geographical location, you still cause the same harm to the Earth system as you would, right? So, but that is in retrospect. Why he was quite successful in doing it, because since then we have the Basel Convention, we have the Bamako Convention, all of them talking about or encouraging trade in waste. And this waste, the only waste that we regulate is hazardous waste. All the rest of the waste, computer waste, clothing waste, everything goes to, it's dumped in developing countries. Okay. Why? Because international law. Now, why does it go to developing countries? Two reasons. One is because there are employment opportunities. Looking at it from 2023 perspective, now there is nothing called waste. Everything is part of what we call circular economy. We extract usable resources from everything that is thrown away. Whether we do it cheaper or more expensive is the difference between the developing and the developed country. Okay. So there is no way I can cheaply use labor in the UK and recycle all my clothing. That's why they go to charity shops in the UK, which then send it off to documented evidence there in Uganda, documented evidence in Kenya, and suddenly you see a lot of kids there wearing football jerseys. Those are the only things that get truly recycled in clothing. All the other types of clothing go and end up in landfills in Uganda, in Kenya. Why? Because environmental laws are either non-existent or the penalties as part of the environmental laws is minimal. Fines, okay? There's not even in prison, even in the UK for spoiling a waterway, the maximum penalty for that is 3 years in prison. You know, and with good behavior and all of that stuff, I can just get it to 6 months and then, you know, possibly not even be there for 6 months because there's a mechanisms of addressing incarceration. Okay, so environmental crime has never been a concept before. But what fits, you know, the summer brief, if there was a concept called environmental crime as a category of legal regulation, then we could actually question that action. Okay. I mean, there's a lot of things we can discuss there, but well done on thinking of a practical example of where the policy was used to justify. And yeah, it's correct. Very good. Usually you find a lot of economic justification that you could easily impute to policies in the US, but they are not the only jurisdiction. Every country, China, Russia, India, UK, Germany, France, even countries like Bhutan, okay, I could challenge saying there is nowadays some element of economic necessity almost. That's what they will say, economic necessity. We all have to agree. If there's no economic necessity.
On which angle will you put health?
Will I put health?
Yeah. On which angle will you put health? Because if you
Yeah.
you succeed in trading waste trading and stuff, of course there is nothing called waste in recent times because everything can be done through waste. But the manner in which it is done determines the success it is done. So in these poor countries, I
would put it as an end because it's the environmental laws that cover health. Yeah.
Yeah. So that's where I'm saying that if it took care of environment, well, of course, like you said, you justified it from the US or UK perspective. But the other part, it means completely it never covered.
Yeah. So this is a problem of jurisdictional law. I would argue, as a public international lawyer and as a cosmopolitan, philosopher, that if we had the possibility of having a global army, which was initially the suggestion when United Nations was first, brought into place. Okay, First World War, to prevent the war of all wars, we started the League of Nations. That failed. Second World War came. Then United Nations came. Then United Nations was set up. The condition was we'll have a global legislature. We'll also have an army to back up the United Nations. But with that didn't materialize. Okay, so if we had global international law, then you wouldn't see the problem shifting forums. Okay, because what you essentially do is the NIMBY problem in environmentalism, not in my backyard. Yeah, whether it is US putting it to developing countries, or whether it is an affluent area in a city pushing it to a less affluent area in another city, and that happens in every country, it's exactly the same legal principle. So it's a question of whether it is international environmental law, which is way less effective, or national environmental law. And if you think about it, can we address climate change properly through law? You also have to ask the question, how effective have national environmental laws been? In a way, that is the crux of the issue, right? And international environmental law can lay standards, can lay targets. National environmental law is the one that has the force of enforcement behind it, right? Because you are able to do it only through national. There is nothing international that exists outside of the territory of the countries. Yeah. So there is a whole plethora of issues that you can think about. Rule of law. That is where the question of whether developing countries have any environmental laws that address and that are up to date in terms of dealing with waste and the shipping and dumping of waste. So it's a question of rule of law. Then you look at existence of environmental law and clear resources and bodies to be able to implement the environmental law. Because some East African countries now, especially Kenya, has very good environmental laws, but does it jump out of the books, and do you have enough people on the ground to be able to monitor it and to be able to, because this is a day-to-day thing, environment is a day-to-day thing. So I guess what you need to acquire skills on is how to analyze each of these, in a way that, you're able to use various of your legal skills, but at the same time are able to provide some diversity of policy options, because that's how we're going to go forward. We're going to have to speak to the widest number of audience as possible. We cannot be hard norm enforcers, nor can we be fuzzy soft law activists. None of it is going to help. You need to have a combination of how you approach it, right. I have a question up there from, who's the question from? Isadora.
Yes, I have another question. So, can you hear me?
Yeah, I can hear you, Val.
Oh, okay. So it's something I think briefly touched upon regarding electronic vehicles. So my question is, I guess it's, so we as society are kind of switching to electronic vehicles slowly because gas is said to have a lot of those emissions.
Yeah.
And leave a huge carbon print. But there's like new research that claims that some studies show that the manufacturing of a typical electronic vehicle battery can result in carbon emissions compared to gasoline cars. That would also include the lithium ion mining. So mining can also contribute to that. So
yeah,
I feel like that's the situation that can kind of make people a little ignorant and delusional, where they could feel like they're contributing by buying an electronic vehicle, but actually they don't know that that is less spoken about. And regarding those studies and research, I feel like it heavily depends on who is funding the research. So, for example, if maybe a company that manufactures vehicles is funding the research, it's usually said that the person who is funding the research or the company is it's more in favor of them. So if maybe a company that is funding research about how much it's affecting the environment, the manufacturing of electronic vehicles, if the results would be that it's like a positive outcome, that could be biased because they're the ones funding it. So I guess my question is how it could how we could, how as society we could go about that. And I feel like a law has to, there maybe have to be some laws that would prevent those companies funding it so that it would up their profit and sales.
Okay. You have raised a very good point, which is in our effort to address the climate change through EVs, that itself is causing another climate change problem because of the mining of materials that is necessary for the components of the electric vehicle. Yeah. So firstly, this is not, we cannot leave this to private standard setting. So companies, you know, trade in what is known as critical raw materials, like, you know, lithium, beryllium, tantalum. There's a group of minerals known as rare earths, rare earth minerals, which are necessary for not just the manufacture of batteries in cars, for the EVs, but also for the wind turbine, which runs the wind energy production in wind farms. They also require these rare earth minerals and materials as components to make the wind turbine. So there are many solutions which are climate change solutions, renewable energy solutions, as well as our transport solutions, as well as our building solutions, which rely on new types of material, which in themselves need to be mined from certain places. So one issue is reliance on critical raw materials that come from certain regions. So China is a big supplier of critical raw materials and raw minerals. Australia supplies a lot of lithium. Democratic Republic of Congo holds huge caches of tantalum and a couple of other raw materials. So I can, you know, you can plot it again around the world. It's not purely in developing countries alone, but there are some other, I mean, good levels of deposit in countries like Australia, which I gave an example of. Canada is another example. So there is that issue of new environmental problems being created because of our energy transition policies that are absolutely necessary for realizing the Paris Agreement. How do we regulate this? The regulation is starting. The example I know of is the March 2023 regulation in the European Union known as the CRM Act, or Critical Raw Materials Act. Now, the objective of Critical Raw Materials Act, firstly, 30% of all of Europe's requirements for raw materials need to come from recycled materials. Okay, so an old wind turbine is there, you take it down, you take all those parts and you need to reuse them. So 30% has to come from there. 10% can come from sources that are virgin or new. Okay, then we need to find another 30% from all sorts of deposits within Europe itself, geographically, so that we do not go to the Democratic Republic of Congo and spoil their environment, do the mining, and also deprive the local population of what they might need and take it away just because we can pay a better price. Okay, the economic rationale. So all these conditions are now laid out in the 2023 CRM Act of the European Union. And the aim of it is to have a sustainable source for the energy transition materials that we need. So this is a good step in the right direction. We need to follow this up in other jurisdictions as well. In UK, we ourselves don't have an act like this, although we have a CRM policy. And that policy is trying to make sure we have a security of supply of these materials, because otherwise our industrial goals for development of wind energy in the UK, because that's a big part of what we rely on over here, is not going to materialize, right? But just because we have this legislation, I am not so sure that we will contain the level of pollution that might be caused by extraction, the level of inequity that might be caused by the global markets, which price these commodities. Okay, that's outside any one country's ability to regulate. So those of us who know international trade law, you cannot actually set these limits anyway. Okay, so there is definitely an issue. It needs to be regulated, and it is part of the arsenal of domestic law to address the CRM, critical raw materials, as well as the rare earth materials required for energy transition. I hope that sort of addressed a few of the points that you were making.
Yes, thank you for clarifying.
Okay, any other final questions, thoughts? Are you happy to carry on with the same format for tomorrow? Because we're coming back tomorrow exactly the same time, right?
Yes.
Yes.
Yeah. You happy with this? Do you want me to change in any particular way? How I'm doing it? Do you find too little content on the slides? Too much content? Any things that you would like me to change? Because, you know, I can tweak things if you would like me to.
I think it's fine. I don't know about others.
I think
Thank you.
It's perfect.
Okay, brilliant.
Everything's great, thank you.
All right, lovely. All right, guys, I won't hold you more. Do have your dinners and everything else. So I'll see you back tomorrow here again. And I'll share the recordings and the PPT, etc. All right. Bye for now.
Thank you very much. Goodbye.
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 Thank you very much.
Bye.
Bye.
Good night, Professor.
Yeah, good night to you. I still have a whole evening. So what do you guys do if you have like classes this long? Do you have dinner during the class, or what do you guys do?